Welcome to Buildings and Beyond,
the podcast that explores how we can create a more sustainable built environment
by focusing on efficiency, accessibility, and health.
I'm Robb Aldrich.
And I'm Kelly Westby.
This episode, I talked with Steve Klocke, who is an architect and senior sustainability consultant here at Stephen Winter Associates. He works with a lot of builders and developers, largely multifamily, especially low-rise multifamily. And he's been asked to do a presentation at several events, several conferences, called We Should Know Better, Top 10 Multifamily Design Mistakes. And it really resonates with folks. It certainly resonates with me. He gets big audiences, so we figured we'd try and talk about it on a podcast. We'll link to the slides he uses in his presentation, which can help visualize some of the things he talks about. But it was really good to chat. This was a long chat, so this week we have the first 5 of his top 10 multifamily design mistakes.
Yeah, well.
All right, number 1. Overcomplicated geometry.
Yeah, okay, so I won't get too deep into architectural theory and what we all learned in school and what we should have learned in school.
And we should say that you are a
I'm
licensed
a registered architect. That is true.
All
I've
right.
been for 13 years now.
All right.
Right. And I wouldn't say that I was ever a hot pencil, would be the term. Like designing things that look great I can make them work, and then make them look good, but making like the really great stuff that wins awards, not my jam. Hence, senior sustainability consultant. But anyway, so at some point in architecture, we got the impression that to make a building interesting, you had to make it sculptural. I don't know, blame Frank Gehry or whatever. And so architects are, for some reason, driven to make their buildings do funny things sometimes. And to me, funny things means bump outs, bump ins, setbacks, jogs in the building footprint. I mean, I've seen building sections that look like a human spine. They jog in and out, and and it's to, I guess, make things look interesting, but it makes the building work a lot harder than it has to. And really, it's all subjective. And again, not being a hot pencil, I can just say that just because I was never good at it, that means I can trash it. But really, very few buildings are going to go out and win a design award, right? Very few buildings you're going to look at and be like, yep, everyone agrees that's a great building. Mostly, everyone is going to have a different opinion, and some people are going to hate your building no matter what you do. So it's very subjective. Things that are not subjective include gravity, heat,
Okay.
wind, rain, all these things that the building has to resist over its entire life. Those things are not subjective. They're objective. And so I think sometimes we put too much of a priority on these subjective design desires and not enough on these objective things that really maybe matter just as much, if not more.
As an engineer, I'm exercising excellent restraint, I think, right now. I couldn't agree with you more. I mean,
it helps that you're tied up with leather belts. Sorry.
I mean, the more surface area, the better. It sometimes seems. How many gables can we cram on this, or how many dormers can we cram on this roof? And it gets.
Yeah, I drove by
a
one
little silly.
on the way home from Albany yesterday, and I almost stopped to take a picture to add to the next time I give this presentation, but I didn't. Traffic.
Yeah. And it turns into all framing. There's no room for insulation. It's just all framing.
You're making the building work harder, and the basis of where I'm coming from is making the buildings easier to actually build. And so I think that results in a building that is going to be more efficient. It's going to be probably less expensive.
Oh, yeah.
It's going to be easier to maintain. It's going to be easier to build in that you're not giving your subcontractors a bunch of surprises. If you can build predictability into the design and a little bit of modularity even, you can really get some momentum going. Yeah. You make the lives easier for the guys and gals who are actually building it, and you're going to get a better product.
Yep, better quality control.
Yep.
And that actually leads very nicely into number 2.
Yes.
Which is design irregularities.
Right. Which, again, maybe they could be seen as the same thing, but they're a bit
But
different.
you're talking
because-
about like the exterior form versus the
Sure.
plans? Is that kind of what you're
Yep,
getting at?
that would be one thing. In a mid-rise, high-rise building, they're very good at lining up their apartments, right? In
Yep.
nice, clean stacks. In low-rise, which is my jam, it's not always the case. You have units overlapping each other. I have a project right now. I swear they were playing Jenga and designing at the same time, and there was some cross-pollination there. And it makes it hard to do your takeoffs for energy models. It makes it really hard to energy model. I've got so many funky little ceilings and floors and whatever. It makes it hard for the contractor. That stuff is going to eventually sag, and it's got more thermal bridging, more structure. They got to work harder to make the building do what it wants to do. Don't don't get cute. Build sensible or design sensible buildings.
And there's a lot. Yeah, I mean, there's a lot. Making a simple building look interesting seems like quite an art. And,
Yes.
And there's some people that are very, very good at it.
Some.
I've seen some very simple plans, simple forms, very functional, and very. I'm not licensed to
As an
express
engineer.
an aesthetic opinion.
Right. That's
as
what
you
Stephen
are,
Winter says. I'm licensed to.
for aesthetics.
Exactly.
But it's good. I mean, we're not talking about shoeboxes. We're not talking about.
Yeah, and even if, I mean, in my presentation, I've got a slide from Park Slope where I used to live, and the townhomes all look exactly the same. And you think those people paid $6 million for their brownstone because it looked the same as the neighbors, or they didn't care that it looked the same as the neighbors? Does it maybe even add to the urban, the street fabric? Well, I don't know what the right design term is, but is there value in things kind of looking more the same instead of everything having to be just a little bit different, and putting all that energy into these little tweaks when you could be putting the energy into refining your details, building some standard practices in that everyone can build efficiently and well.
All right. Nice.
Yeah.
All right. Now we're switching gears a little bit.
More technical now. That
Thermal
was all very fluffy. Yes and no.
I can't say that. You can say that. I'd be pilloried.
No.
All right, thermal bridging, roofs and walls. This is a nitty-gritty performance issue.
Yes. And we have our passive house friends to thank for really making this more obvious to the rest of us. So when we do all these energy models, actually, my friend Charlotte she's working on a project in Toronto where one of the key things that they're looking at is the difference between modeled performance and actual performance of these buildings. And there is a difference.
Yeah.
And where does that difference come from? And one of the things in the envelope that contributes to this is thermal bridging. So roofs, in New York City.
Should we define it quickly?
Thermal bridging is, go ahead.
Well, we're in a framed home, for example, if you have a 2x6 wall and it's filled with R19 bats, the studs themselves only are about R5 or something.
Wood is R1 per inch. Yeah.
All right, so 5.5. Excuse me. So that lesser R value kind of diminishes the performance of the whole wall.
Right.
And by adding rigid insulation on the outside, Bill and I talked about this in the Envelopes podcast.
Yeah.
You add more. If you put R5 rigid on the outside, you add more than R5 to the whole assembly.
Exactly.
Because you reduce the bridging.
Yep. And that's the point. So in roofs in New York City, at least with mostly low slope roofs, it's not a problem because the typical detail is a few layers of polyiso on top and you're good to go. I will say though that in the newest version of the building code, they added a table that was actually only in the residential code for years, where if you have an unvented ceiling or attic assembly, a certain percentage of the R value, if you're using air permeable insulation, has to be above deck. So like if it's an R38 roof, you have to have R15 continuous above, and then you can do your bats down below. And it doesn't apply if you do spray foam or whatever, but I still see drawings come across my desk that haven't picked that up. And, again, thermal bridging, it's not only a loss of performance, but it's also potential for moisture condensation. And you got durability issues and indoor air quality issues, and et cetera, et cetera.
Yep.
So,
Makes
yeah,
sense.
roofs, low slope roofs aren't bad except for when you get around roof drains. If a good architect will say, R15 minimum at the roof drain instead of going from 0 to whatever.
Okay.
The walls are really where it's at, and especially masonry and especially steel framed walls. That metal is so conductive. I mean, if you're not putting rigid insulation on the outside, and I know for code that's an option, or you can try to load your wall full of closed cell spray foam, but who wants to pay for all that? Just do some bats on the inside and then a couple inches of rigid on the outside, and Bob's your uncle.
And do you see steel framed walls with insulation in the cavities and nothing else?
I see it come across my desk.
You see
I
drawings?
don't let it off of my desk.
You still see drawings where you have steel framing, bats in the steel framing, and nothing else.
Yeah, I still see low slope wood frame roofs with our 38 bats between the joists, nothing on top. And that's just, and a lot of this is the title of the presentation is "We Should Know Better," and so I have to tell people at the beginning of my presentation, look, hopefully you will have heard about all of these issues before, or at least hopefully been aware of them, and maybe just need to be reminded or whatever. But it's not rocket science. These are things that we should have figured out a long time ago, and they just, for some reason, keep finding their way into these construction documents.
All right.
Yeah.
All right.
So the subcategory, or the next one for thermal bridging, is at slabs. And this is, I would say at least 50% of my projects, first time I see the drawings, and this is hard to do on the radio or podcast or whatever, but the insulation is drawn behind the foundation and under the slab, if you have a slab on grade foundation. And so you have a nice little L, kind of like an inverted L, but you have continuous concrete vertically and horizontally. So A, you don't need both the vertical and the horizontal, you only need one. B, you need to get the insulation either on the outside of the foundation and make sure the top of it is contiguous with the above grade wall insulation, or you can leave it on the inside of the foundation and at least separate the slab from the foundation if you don't have a structural slab. And man, that's one that architects for some reason just have a really hard time wrapping their heads around.
First of all, I think passive house people wouldn't necessarily agree with you that you don't need sub-slab insulation. And
Right. Let's clarify. So my projects are mostly low-rise, multifamily, affordable. We're not pursuing any of the advanced certifications.
All right.
We're just pursuing the
house.
base, Energy Star, LEED for homes or green communities.
And when you talk about slabs, are we talking about basement floors, or are we talking about slab on grade?
Slab on grade.
Okay.
Yep.
Big difference.
There's a difference.
Okay.
Well, yeah, and the diagram in my presentation shows, we've got insulation starting at 6 inches below grade going down to 24 inches below grade. What about 0 to 6 inches below grade? That's the coldest part. The ground gets warmer the farther you go down, hence the frost depth for your footings. And so the coldest part of the foundation is the part that's not getting any insulation.
Yeah. That's been 20 years ago, I was dealing with that. You talk people into.
We should know better. Yeah.
I've seen it so many times where in a basement, insulating the outside of a foundation wall, and you get to above grade. Mm-hmm. Well, I don't know. I don't want the foam. I don't want the foam above grade. I'll just cut it at grade.
Yeah.
And leave the top 18 inches.
Because they want to see that concrete. Yeah. Or they don't want to cover it. And it is a tricky detail to cover it on the outside if you have a lot of exposed foundation.
This is one of the trickier details, I think, to get right.
I will definitely concede that.
And in the show notes, can we put links to some resources, you think, that have good?
Yeah.
All right.
Yep.
There are good details. We can put a link to at least one of your PowerPoints.
Sure.
That has some examples of that.
A couple slides there, yeah.
Okay. All right, number 5.
It is not rocket science, though.
No, but I can.
Yes, but we get it.
But it can be challenging and it can be different, and anything different is, yeah.
Right. Agreed.
All right.
If it was easy, we would have wrapped our heads around it a long time ago, and it wouldn't be on my top 10. Yeah.
Fair enough.
Okay.
Number 5. poorly detailed air barrier.
The trick to air barriers is that you have to draw them
So this is on plans. This is on
on plans
Okay.
or sections, and especially details.
Okay.
Yeah, and so actually that's really how it should work. Is you have that air barrier continuity, big fat dashed line running across your building section, top, sides, and bottom. And then you zoom in and you're looking at every jog in the building if you just couldn't help yourself. every material transition, every assembly transition, floors to ceilings to walls, etc. And you're zooming in all the way down to the level where the general contractor should not have any questions about how you expect their leakage requirements to be met. Now, he or she can say, oh, I would rather do it this way. That's fine. But if you don't have something to start from, what happens is I get out there in the field as the building's being framed. Contractor looks at me and says, what do we got to do? And I say, well, what's in the drawings? And they say, this is what's in the drawings, but we don't know what it means. Or it's just buried in the specs somewhere because it's buried in the code somewhere. And who looks at specs? Let me take that back.
And
several GCs look at specs, but are they sitting out there, in the job trailer, or are they in someone's tool belt as they're walking around the building? No.
It's hard.
Yeah.
It's hard to find things from specs. Oh
Yeah.
my God. It really is. Yeah.
Well,
so
with
what
the
are some of
advent
the
of-
examples? What are some of the examples you see? I mean, give me an example of an air barrier that's just.
Well,
that's-
first of all, we shouldn't mention any trade names, but let's say a sheet air and water barrier product that one would typically apply to wood framed construction
on the outside.
on the outside of
Yes.
a building.
Built
And it has
paper,
a tendency
building
to
paper,
building
house wrap.
paper, house wrap.
No brand names.
No brand names. Something like that can work well as a water barrier
Sure.
if it's installed correctly, which between you, me, and whoever's listening, it never is. It can be. There's less of a chance that it's going to be an air barrier, and I can safely say it is never installed in a way that it's going to achieve complete air barrier like
Air barrier.
you and I would expect to
they've
see.
stopped claiming that.
Have they?
Those manufacturers have not been claiming that.
Oh, good.
They call it a water-resistant barrier or a drainage plane.
Okay, so they do know better by now.
That-
But do the people using it know better by now?
Well,
That's the
that's the issue. Yeah. No, I
Yeah.
have house wrap. That's my air barrier.
Yeah.
And it's even right. It's not. It's lapped. It's got staples in it.
Lord knows it's flapping in the wind for
Yep.
however many months while they're waiting for the weather to warm up so they can put up their cladding, whatever.
Gotcha. Whereas, and if this is a framed construction, what do you like to see for an air barrier?
Well, we've started seeing a lot more of the, again, not naming any products, but the sheathing with the air and water barrier built into the outer layer. That seems to have a lot better results because it is more manageable.
And tapes all the seams there. Very important to tape those seams properly.
Exactly. Yeah.
Okay.
And a liquid applied air and water barrier. We don't see all that often on low-rise wood frame, but
Right.
obviously in steel and masonry, it's the norm.
Caulk and foam from the inside.
Caulk and foam from the inside, yeah. We're starting to backpedal a little bit on spray foam. Spray foam is good to use in certain areas when it's really hard to do anything else. But if you're looking at the global warming potential and all that stuff, we've really started to see either fiberglass bats or cellulose, as long as you've got a good layer of rigid insulation on the outside, which also has its own global warming potential. Unfortunately, it's all a bunch of trade-offs really. You can achieve the same tightness if you've got a good air barrier in that assembly and all the way around.
All right.
Yeah.
Thanks for listening. That's the first 5 of the top 10 multifamily design mistakes. We'll do the other 5 next week. Thanks.
Thank you for listening to Buildings and Beyond. For more information about the topics discussed today, visit www.swinter.com/podcast and check out the episode show notes. Buildings and Beyond is brought to you by Stephen Winter Associates. We provide energy, green building, and accessibility consulting services to improve the built environment. Our professionals have led the way since 1972 in the development of best practices to achieve high-performance buildings. Our production team for today's episode includes Dylan Martello, Alex Mirable, and myself, Heather Breslin. Thank you for listening, and we'll see you next week.